Welcome, Mars farmers. You have a mission. So your mission is to build that water filtration system that's going to save not only your life, but it's going to save the life of your crop, of these precious soybeans. These soybeans are going to be possibly what gets you off of this planet. So we use them today for a lot of different biofuels, and you might be the scientist who discovers how to change that into rocket fuel to help you get off the planet. So saving your crop is going to be very important. This water filtration system is critical for life. So before we start, we're going to start with safety. Remember to always wear safety goggles when you're doing a lab. So I'm going to put my goggles on. The second thing I want you to remember is never ever eat or drink anything in the science lab, even though it might be food. So today, keep that in mind. Even after we build our water filtration system, do not drink the water. This is our wastewater. Now remember, when you watch the video, astronauts have to recycle everything and reclaim every bit of water that's on the space station. So including sweat, water vapor, and yes, urine. So they have to reclaim everything and recycle it because it is too expensive to ship more water up to the space station. You have a few supplies on your Mars module. So you have some beans, you've got sand, you also have cotton balls, you have aquarium gravel, you've got this thinly type of gauzy material called cheesecloth. You also have some macaroni. You've got activated carbon as well. So you're going to use all of these supplies to build your water filtration system. You can use as many as you want, or you can use as little as you want. It's your decision. The second thing we have available are water bottles. So you're going to take your water bottles and you really can design them however you choose. I chose to cut off about 2 centimeters from the bottom of each bottle. So that was my design that I chose. But before we start with our design, we've got to look at our data sheet that we're going to collect. So the data that you're going to collect today includes finding the pH of the water. Remember, in the video, the ISS uses, after their water is reclaimed, it has to be a pH of 6.5 to 8.0 before astronauts can drink the water. So if you have a pH indicator that has the full range, the full scale 0 to 14, that would be ideal. However, today I do not have one of those. I am using a 5-in-1 pH strip that I picked up at the pet store that people often use for their aquariums. So you're going to take out one of these strips and we're going to just measure the indicators actually on the side of the bottle. So the first thing we're going to do is we are going to pour up 200 milliliters of this wastewater. So I'm going to use this smaller beaker here, and it goes right to 200. So I'm going to measure that out. Lots of goodies floating around in that water. All right, it looks like I'm right on. Yes, okay. I'm going to recap the wastewater. And I'm going to mark down the volume of my wastewater, which is 200 milliliters. The second thing that I'm going to do is I'm going to take my strip and I'm going to dip it in the water for just a couple of seconds, making sure I get down to the very bottom indicator, which is the pH indicator. And when I measure that, I can see that my acid of this water is fairly high. So it's sitting right at about a 4.0 level, which is higher in acid when you look at this pH scale. So acid level, that might be the same as like a tomato that you would eat at home. So about that acid level. It's too much. So we're going to change that with our water filtration system. The next thing that we're going to do is we're going to just make observations of the water. Look at the color, the cloudiness. I see a lot of particles floating around in there. Kind of decide on a percentage of the particles that you see. I would say probably about 10% of particles floating around in there. And then just list those observations on your data sheet as well. The next thing that we want to do is we want to find out the weight of our filtration system, because that counts in space. When you try to move things up there, weight is very important. So I'm going to turn on my scale. If you have a balanced scale, that would be ideal, but I don't, so I'm just going to use my kitchen scale. I switched it over to grams. I'm going to weigh my bottle. You know what? I want to weigh it without the cap, so let me just do that again. And I'm right at 16 grams for the empty bottle. And then once I create my system, I'm going to weigh it again and subtract the two to get the difference, and that'll give me the weight of my system. So the first thing I'm going to start off with is I'm going to take some of this cheesecloth and I'm going to cover the lid. I'm going to grab a rubber band so I can secure that into place. Once that is secure, I'm going to start to build my system, and I think I want to start off with a coffee filter. And so I'm going to grab one of these coffee filters, and sometimes these stick together, so you'll have to pull it apart a little bit. And I'm going to put that in first. And then I think I'm going to add my sand in. So I'm going to use a little bit of sand. I'm going to use that filter to kind of help hold it in place. And then I think I'm going to add some cotton balls next. And then after that, I'm going to put in some of this really cool colored gravel there. So I have a layer of the gravel. Maybe add some beans in there. And I'm going to use some of this activated carbon, and actually make sure you rinse it a couple of times before you use it, because that will have an effect on it as well. So this is pre-rinsed. I'm going to put some of that in there. And then I'm going to top it off with some macaroni. Why not? Just a little bit. I'm going to tamp things down just a tad. Now, I can tell I've added quite a bit of weight to my system here. So, then I'm going to weigh it a second time. I'm going to turn my scale back on. I'm going to set this carefully on the scale, and I'm going to keep my hands there in case it decides to tilt or spill. So now I'm at 382 grams. So I'm going to subtract that 16 grams from that number to get my total weight of my system. All right, now here comes the big test. So I'm going to use my second water bottle. I'm just going to set that there for a second. And run it through. So I designed mine. If you wanted to, you could even design two systems that it runs through. But remember, you want to retain as much volume as possible. So the more you add, the more effect that's going to have on what you have. So let's slowly run this through and see what happens. See how much volume is left, and see what happens to that color. So you can already tell that color has lightened up ever so slightly. And you can also tell that we have lost quite a bit of volume of water. I'm sitting right now at about 50 milliliters. And it's gonna slowly drip out. We might even let it hang here for a little bit. You might even give it about maybe, 5 minutes wait time to see how much more water is gonna come out. So you do lose quite a bit of volume when you build these water filtration systems. So the next thing that we're going to do is we're going to test that, set that right there. We're going to test our pH a second time. So I'm going to get out another pH strip, and let's see if we were able to change the pH of that water. So you can kind of see the difference of where we started and where we ended up. It's a little bit cleaner. Definitely the debris are clean. I notice it's a tad bit cloudier than what it was originally, so you might want to note that on your data sheet as well. Let's get our test strip out. We're going to dip it in here for a couple of seconds and hold it back up to our indicator, and really our pH has not changed that much at all. So when you build a third system, then you can, or a second or third system, then you can start testing that pH and testing more of the different items to see what might bring that pH down. to the right level to where you as an astronaut can drink it, and also to plant or to water your soybean crops. So as we know, science is a human endeavor, and so as you're going through the engineering process, you're going to learn from your failures and you're going to learn from your mistakes. So with that failure of our water actually turning that grayish black color, that's going to give you an opportunity to think about what you did, how you layered your products that you had, and then think about how you might do that differently to get that water a little bit cleaner. So definitely failures are part of the engineering process. That's how we learn. That's how we improve upon what we have designed. So don't let that first failure discourage you. Just keep trying and go through that process, that engineering design process again, and think about ways to change it, to tweak it, to rethink it and make it better. So it's a good part of, that's how we learn. Failures help us to learn. All right, good luck, Mars farmers. We need you in the future, and good luck with your system.